Earth has a companion nobody told you about. It's been following our planet for who knows how long, and a Chinese spacecraft just got close enough to touch it. Here's the strange part. Scientists aren't sure if this thing is an asteroid or a piece of the moon itself. Let that sit for a second. A chunk of our own moon, possibly blasted into space, that's been quietly riding along next to Earth this whole time. And we almost missed it completely. Its name is Kamoʻoalewa. It's tiny, really tiny. When it was first spotted, astronomers thought it might be up to 100 meters wide, roughly the size of a football field. The first close-up photos suggest it could be closer to 20 meters. That's more like the size of a house, which means this could be one of the smallest objects a spacecraft has ever visited up close. It was discovered in 2016 using a telescope on top of a Hawaiian volcano. That's actually where the name comes from. Kamoʻoalewa means something like oscillating fragment in Hawaiian. Fitting, because this thing does not behave like a normal asteroid. Most asteroids just orbit the sun on their own path and don't care about Earth at all. Kamoʻoalewa is different. It orbits the sun too, but it does it in a strange rhythm that keeps it looping near our planet, over and over, for centuries at a time. Scientists call this a quasi-moon. It's not orbiting Earth the way our actual moon does. Think of it more like a car that keeps ending up in your neighborhood every few months, without ever actually parking in your driveway. There are only 7 known objects like this near Earth. Kamoʻoalewa is one of them. And out of all 7, it's the one that scientists became obsessed with. Why? Because of what it's made of. In 2021, a team of astronomers pointed a powerful telescope at Kamoʻoalewa and measured how it reflects sunlight. Different materials reflect light differently. It's like a fingerprint. And the fingerprint they got back didn't look like a normal asteroid. It looked like moon rock. Specifically, it matched the weathered lunar soil that Apollo astronauts brought back decades ago. That is not a small coincidence. Scientists started connecting the dots. If this really is a piece of the moon, something had to have knocked it loose. And there's a prime suspect. A crater on the far side of the moon called Giordano Bruno. It's about 22 kilometers wide, and it's geologically young, meaning it formed sometime in the last few million years, which in space terms is basically yesterday. The theory goes that an impact big enough to carve out that crater could have thrown debris into space, with enough force to escape the moon's gravity entirely. Some of that debris, the theory suggests, became Kamoʻoalewa. It's a compelling story, but it's still just a theory. And that is exactly why China built an entire spacecraft to go find out. That spacecraft is called Tianwen-2. It launched in May 2025, and it spent more than a year crossing over 1 billion kilometers of space to reach this tiny rock. In early July 2026, it finally closed the distance to about 20 kilometers and took the first ever close-up photo of Kamoʻoalewa. And that photo immediately complicated the story. Because based on that image, and new data from the James Webb Space Telescope released just days earlier, Kamoʻoalewa appears to be smaller than anyone expected. And a smaller object reflecting the same amount of light means it's more reflective than scientists had calculated. That changes the numbers. Some researchers now argue the surface may actually fit an entirely different kind of space rock, an ordinary stony asteroid, not lunar debris at all. Others still lean toward the moon fragment idea, just from a different impact, possibly the crater Tycho instead of Giordano Bruno. So right now, nobody actually knows. The closer this spacecraft gets, the less certain the answer becomes. That's not a failure of the mission. That is exactly the kind of moment scientists live for, when the data stops fitting the easy explanation. There's another wrinkle. Kamoʻoalewa spins fast. It completes a full rotation roughly every 28 minutes. For a spacecraft trying to land on it, that's a serious problem. Imagine trying to place your hand gently on a spinning ceiling fan. Now imagine you also don't know if that fan is solid metal or a pile of loose gravel barely holding together. That uncertainty is why Tianwen-2 wasn't built with just one plan. It's carrying 3 different sampling methods. One is a quick touch and go, where the spacecraft brushes the surface for a second and grabs whatever it can. Another involves hovering just above the surface, and the third, never attempted on any asteroid before, involves the spacecraft actually anchoring itself to the rock and drilling in. Which method gets used depends entirely on what the surface turns out to be, and nobody will know that until the spacecraft gets close enough to see for itself. If everything goes according to plan, Tianwen-2 will spend months mapping Kamoʻoalewa before attempting to collect a sample. The mission is aiming for somewhere between a few dozen grams and up to a kilogram of material. Then it heads back toward Earth, dropping off a return capsule expected to land sometime in 2027. After that, it doesn't stop. It uses Earth's gravity for a boost and continues on toward a much stranger target, a comet with a bizarre 6-pronged dust tail, arriving nearly a decade later. But the part that matters most happens before any of that. It happens the moment that sample lands back on Earth and scientists finally get to look at it directly, instead of guessing from reflected light hundreds of thousands of kilometers away. Because right now, everything we think we know about Kamoʻoalewa is built on inference, light patterns, size estimates, educated guesses stacked on top of each other. A physical sample changes that completely. It would either confirm that a piece of our own moon has been quietly circling near us for millions of years, or it would prove that Kamoʻoalewa is something else entirely, an ordinary wanderer from the asteroid belt that just happens to mimic lunar rock closely enough to fool us for years. Either answer tells us something we didn't know about our own solar neighborhood. This isn't a story about danger. Kamoʻoalewa poses no threat to Earth, but it is a story about how much can hide in plain sight, close enough to study, and still remain a mystery for years. Sometimes the most interesting discoveries aren't the ones that come screaming in from deep space. Sometimes they're the ones that have been quietly orbiting beside us the whole time, waiting for someone to finally take a closer look.